Hello everyone, I am Charishma and in this video I'll take you through my data warehousing and mining project using the Airbnb New York dataset. But this isn't just a high level overview. We are going to walk through each line of the code and I'll explain what's happening and why we are doing it. If you are learning Python pandas or want to understand how to analyze real world data, this video is for you. Moving on to the code, we start by importing all the necessary Python libraries. Pandas is the go-to library for working with structured data like reading CSVs and handling data frames. NumPy uh, helps with numerical computations, and matplotlib.pyplot is used for basic plotting, and Seaborn builds on that to make more visually appealing plots. And from sklearn, we bring in standard scalar to normalize our numerical features. K-means for clustering listings into meaningful groups, and silhouette score to measure how well the clustering performs. And this line loads the Airbnb New York dataset into a data frame called DF. Um, reads ASV reads the file and stores it in a table-like format. When we use df.head to display the first five rows, just to quickly examine the data and get a feel for the columns. And then here we print the shape of the data set using df.shape, and this tells us how many rows and columns we have. For example, the output 48,895 rows and 16 columns. These are the number of listings and these are the number of features. And this line checks for the missing or null values in each column. Each creates a Boolean matrix of true or false for each missing value, and dot sum gives us the total count of how many nulls exist in each column. And this step is essential to prepare the data for cleaning. We handle the missing values very carefully. If a listing is missing a name or host name, we fill it with a generic placeholder like unknown in the case of name and host in the case of host name. And if the listing has no reviews per month, we assume it's zero. And for last review, we fill the missing values with default date, that is January 1st, 2000. These strategies help retain the rows without introducing noise. And this block ensures data quality. Drop duplicates function removes any repeated entries that could skew our analysis. Then we filter out listings that are either priced unreasonably high, above $1,000, or have an unusually long minimum stay, more than 365 nights. This keeps our data realistic. Uh, and then we use dot d types to check the type of data in each column. For example, integers for id and price, and then floats for latitude and strings for name. And uh, last review is supposed to be in the datetime format, but since it is in the object format, we change it to the datetime format. And then if we recheck the data types, here we find that last review is now in datetime format. And then this line creates a new column called price category. We divide prices into three bins. 0 to 100 is low, and 100 to 300 is medium, and 300 to 1000 is high. And pd.cut helps convert the numerical data into categorical ranges. This will help us visualize and compare listings by price tiers. Moving on to the data visualization part, this histogram shows how the prices are distributed. Uh, we use 50 bins for granularity, and KD equal to true adds a curve to better understand the distribution. And we limit the x-axis to 500, to remove the outliers from the skewing plot. And we notice that from the graph, the listings are priced under 200, most of the listings, uh, confirming that New York City's Airbnb market leans toward affordability. And then this count plot shows the distribution of types of rooms in each borough. Uh, Manhattan has the highest number of entire homes, and the private rooms are in Queens and Brooklyn. Private rooms are higher in number than other counts of rooms in those cities. This gives us insight into the kind of accommodations offered by the area, and this is plotting the correlation heat map. This heat map shows how strongly numerical variables are correlated. For example, price is weakly correlated with reviews, but the number of reviews and reviews per month have a strong correlation, about 0.59, which makes sense. More reviewed listings tend to get more frequently. And then uh, this plot shows the number of listings in each price category. Previously, we have categorized the price ranges into three different bins, and this plot shows the in which category the higher number of listings are there. We noticed that low price category dominates the dataset, and then this plot is the room type versus the price category. Um, and we noticed that um in low price category, private rooms are high in number, and in medium price category, entire homes are high in number. Uh, and in high price category as well, the entire homes are high in number. From this, this is the conclusion we can draw, that private rooms dominate the low price category while entire homes apartments become more common as prices increase. Shared rooms remain rare across all the categories. And then this plot shows the average number of reviews by price category. Um Low price category Airbnbs has the highest number of reviews, and followed by medium, and followed by high. From this, we can conclude that listings in a low price category tend to receive higher number of reviews, most likely due to the affordability uh, and higher booking frequency. And then here we select the moving on to the feature scaling and clustering part. Here we select the features we want to use for clustering. For example, here we used price, minimum nights, number of reviews, and reviews per month, and then we standardize them using standard scaler. This helps. This step is essential because K-means is sensitive to the scale of data features, with large values could dominate otherwise. And then elbow method to find the optimal clusters. We try clustering data into different number of groups from 1 to 10. uh, inertia measures the how tightly the data points are grouped in each clusters. We save these values to visualize the elbow curve next. Elbow curve is used to find the optimal k value. For example, in this elbow curve, we see that there is a sharp cut at 4. So most likely we take k value as 4, but still we also want to go with the silhouette score. Uh, in a silhouette score tells us how well separated the clusters are. We try different k values and calculate the scores. The higher score means better clustering. Here are the scores for each k value. Uh, since k equal to 2 and k equal to 4 have almost similar values, though k equal to have a bit a very less more higher score, since in the elbow curve we notice the k that 4 is optimal. We are taking 4 here. uh, so here we apply K-means clustering with 4 clusters. We assign a cluster label to each listing. Then we create a scatter plot to visualize how listings are grouped, like in here. This helps identify patterns like budget friendly or high traffic listings or premium exclusive homes. And then now we are moving to the classification part of the project. We want to predict if a listing is popular. So here we define listing as popular if number of reviews is greater than the median number of reviews. The condition inside the parenthesis returns true or false error array. We use dot as type of int to convert true to 1 and false to 0. The new column uh, is popular becomes our target variable. And then splitting our data for training and testing. Next, we prepare the features X and target Y for training. We include price, minimum nights, and reviews per month as features. Then we use train test split uh, to divide the dataset into training and testing datasets. And then random state ensures the reproducibility, so we get the same split every time. And then we create a logistic regression model which is suitable for binary classification. uh, So we imported logistic regression from linear models. This regression function uh, initializes the model. Dot fit train dot fit trains it using the training data X train and Y train. This model will this model will learn patterns in the data to predict if the listing is popular. And after training, we use dot predict to generate the predictions for the test set. Then we use classification report to evaluate the model. It gives us precision. Uh, Precision tells us how many predicted popular listings are actually popular, and then recall tells us how many of the actual popular listings were correctly predicted. And F1 score is the harmonic mean of precision and recall, and finally accuracy. The next step is plotting the ROC curve. The ROC curve helps us visualize the model's performance at different classification thresholds. We get prediction possibilities using predict.proba function, especially the probability of class 1 popular listings. Here it is. And then ROC curve calculates the false positive and true positive rates, and ROC underscore AUC underscore score function gives us the area under the curve, a single metric to summarize how well the model is performing. The closer the curve hugs the top of the left corner, the better. And I want to wrap this up. So, what we can achieve in the project? We started by cleaning and pre-processing a real Airbnb dataset. We explored price distributions, room types, and correlations between the features. And we used K-means clustering to group the listings into 4 behavior-based segments. And finally, we trained logistic regression model to predict which listings are likely to be popular with a decent accuracy. And this project demonstrated a key warehousing and mining concepts, from cleaning raw data to modeling insights, all on real world data sites. Thank you so much for watching.